This is really important because in order to use the rules for differentiation that we've been using, we have to have a function that's something called differentiable. Let's now take a look at differentiability. And differentiability, also known as f of x is differentiable, this is talking about the derivative. A function f of x is differentiable at c if f of x is continuous, just like we were just talking about, and we can find the derivative f prime of c at x equals c. So to be differentiable, we need the following things. One is that the function must be continuous. So we do the test exactly like we did before. Second thing, the derivative, remember that's the slope of the tangent line, must be the same as we approach from the left and the right. And then 3, the derivative cannot be infinity. So on a graph, we can just sort of look and spot these things. F of x is not differentiable at a for each of the following. If there is a discontinuity, so that'd be like this, not differentiable, or here, even though there is a limit, it is not continuous, so f of x is not differentiable. And the reason for this is that if you imagine trying to draw a tangent line at this point, well, there are a bunch of lines that you could make the case for being the tangent line. I mean, here this only touches at one point, this only touches once, and so on and so forth. And while none of those are exactly the tangent line, because the tangent line is sort of that one that just brushes the curve, and there's really only one tangent line per se, this kind of doesn't have any tangent lines. There are a whole bunch of lines that we could draw, none of them is really a true tangent line. Another situation is that we could have a sharp turn. So that's something like this. Actually, that should be moving back on itself. It should just be moving up like that. So right here, this is at A. A sharp turn means that if we were to try to draw a tangent line, well here when we're doing it this way, we're sort of drawing tangent lines like this. It's sort of like off the end like this there. But when we come from this side, we're drawing tangent lines, and it's definitely sloping up while this one's sloping down. And so what's happening is that there isn't a single tangent line that we can draw exactly at A. We can draw a single tangent line over here, we can draw one over here, but not exactly at A. They sort of conflict. The slope of the tangent line coming from one direction is different than the slope of the tangent line coming from the other direction. The final non-differentiable point at A is this one. Here, slope of the tangent line is infinity. And the reason this is a problem really is because this infinitely sloping upward tangent line, it's really caused by a rise over run where the run is 0. And basically what we're doing when we find the slope with a run of 0 is we're dividing by 0. If that run is 0, we have division by 0. Not allowed to have that happen. So these are the three things to look for: discontinuity, a sharp turn, or an infinitely sloping tangent line. So let's do a quick example. At what values of x is f of x not differentiable? Here's our little f of x. And so what we're looking for is we're looking for any discontinuities. So clearly not differentiable. Discontinuities. So that would be x equals -3, x equals 1, and x equals 3 right there. It's also not differentiable at a sharp turn. So that's right here where we have a sharp turn. Anywhere else is fine, so if it's sort of like a maximum or a minimum, that's totally fine. We just can't have any sharp turns. Or vertical tangent lines. And that occurs right here, where x equals -4. Maxima and minima are okay. By definition, their derivative is 0. We can find the derivative. 0 is just a number like any other.